Hi everyone, Cody here. So I wanted to briefly talk about another one of my crazy ideas that I don't suggest we actually attempt, but it is fun to think about. And the idea is to dig a really deep hole on Mars in order to make a portion of the planet habitable. At least to the point where a human could go out without a pressure suit, only needing maybe an oxygen mask. But maybe you could grow plants and stuff. So if you've ever been on a hike on the Earth, as you go up in altitude, the air pressure drops, and you go back down in altitude, the air pressure rises again, right? The air pressure changes exponentially because gravity is pulling on the air, compressing it. And the same happens if you were to go into a large hole. The air pressure increases as you go down in altitude, right? So, how deep of a hole would you need for the atmospheric pressure to be high enough that a human could survive without a pressure suit? Well, it's about 25 kilometers in depth. Now that's pretty deep. On Earth, the deepest humans have ever gone is about 12 kilometers. And the problems they would have is the pressure from the rock. You know, this 12-kilometer high column of rock has a lot of weight, and that weight causes the borehole to want to be closed up. Also, the temperature was so high down there, the rock behaved more of a plastic than a brittle material. So it was like trying to drill through high pressure honey. It just kept closing the hole. Now, that wasn't really a hard limit. They could use a drilling fluid to provide back pressure to help hold the hole open and also cool the rock so it doesn't try to flow in as much. But really they just ran out of money before they could get much deeper. But on Mars, let's say we had this similar amount of effort to try to dig a hole. How far could we go? Mars is a smaller planet, so it's got less gravity. The rock is not being pulled down as strongly. It's about only 40% as much. And plus the planet's small size means it cooled off faster. It's not producing as much heat, so the thermal gradient is much less than on Earth. I think the estimates are that it's about 1/4 as much. So to get to the same conditions we had at the bottom of the Koala super deep borehole, the hole would have to be about 50 kilometers in depth. That's more than the 25 we need. So that could work. But I do not propose we live inside of a small borehole. I want something big enough that you could see the stars at night, that you can see the sun during the day. You know, it needs to be an open hole. So I'm thinking something like an open pit mine, similar to the Bingham copper mine here in Utah. The angle of repose for rock is about this, on large scales, is about the same as sand. So this angle is about 30 degrees. So that means that for a 25-kilometer deep hole, the top of the hole is going to have to be about 100 kilometers wide. That's a big hole. That'd take forever to dig, right? But I propose we dig it out in a much shorter time than we were expecting. I say we take an asteroid, about the size of the one that killed the dinosaurs, and slam it into Mars at the deepest point of Mars, so the bottom of the Hellas impact basin. Just put a crater inside of a crater. So this asteroid's going to hit the ground on Mars, and it's going to blow material out as the asteroid inverts itself, delivering that energy. That creates a shock that goes into the ground. The shock that's going sideways blows material out. The shock going down compresses the material so that after the impact, the profile of the crater is going to look kind of like this, kind of a W shape. There'll be a central peak as the ground rebounded from being compressed. So a 100-kilometer wide crater. It'll be around the same depth as the asteroid was wide, roughly. That's Newton's impact penetration laws. The central crater, of course, is going to make the center of the crater less deep. But I say we take another asteroid and hit it again. Blow that central mountain out, basically put another crater inside the crater, make that, and then do it again and again until you get something that's more of a conical shape, like this, blowing the material out. This process could be done very quickly. And you could do it because the thickness of the crust is enough that that could work. Who knows what that would do to the rest of the planet, but there you go. Now you've got a hole. It's 100 kilometers wide at the top, 25 or more kilometers deep. Now the atmospheric pressure is high enough that you could walk around on the surface without a suit on. But also what it would do is you're trapping all this gas inside of this hole. You know, it's coming in from the rest of the planet and filling that hole in. So now you've got a thicker atmosphere. So heat that's being generated from down here from reflected sunlight and from the thermal energy of the planet going up is going to be reflected back down to the greenhouse effect. So this bottom of the hole is going to be a lot warmer than the rest of the planet would normally be. So not only is the pressure going to be higher, but so is the temperature.